everyone, I am Pranita. I am here to teaching you chemistry. So in today's class we will discuss some properties of the nature. So here we will discuss D and F block elements. First we will see the introduction of D and F block elements. If you clearly observe this picture, what you can see? A father and mother playing with a baby in the outside, right? So here, can you see any other color? So we are observing all are in black color, right? So here all are in black color. So now look at this picture. Here what is this? Rose. In which color it is? White in color. Next, here it is hibiscus. So it is also in white color. So like this, if all the things are in white color, like walls, chairs, door, and even the bed sheet and whatever the things we are using, if they are all in white color, how you feel? Here white appears good, but are you satisfied with that white color? Not at all, right? So here, if all the things are in white color, we are not satisfied, we'll get bored, right? So that's why. But if you observe the nature, all the things are in the different colors. So if you go to the outside in the rainy season, you can see the different colors surrounding you, right? So here we will get a doubt after observing this. How nature makes so colorful? Okay, how the nature making them so colorful? So actually this is a good question, right? It is a pretty good question, but what is the answer for this question? How the nature is giving the different colors to different things. For example, if you observe the leaves are in green color, right? And those flowers are in different colors. Just now we saw the rose and hibiscus. Actually hibiscus is available in the two different colors, white as well as red, but mostly it is available in red color. And roses, nowadays roses are available in the different colors. So same like that, the different things surrounding us are having different colors. So why these objects are having different colors? So it can be answered when you carefully go through the nature of elements. Already we know the elements. So here if you clearly go through the nature of these elements and their behavior, then you will get the answer. Okay, so here what are those elements? D and F block elements. So mostly here D and F block elements are available in the ionic state. So in those ionic states they exhibit the colors. Okay, so here to know that we will learn first about the D block elements. Okay, D elements are D block elements. Okay, so in the 11th standard, in the previous class, we already learned about the periodic classification of elements, right? So if you clearly observe the periodic table, so in that periodic table, we know that it is divided into 4 blocks. Yes, P, D, F. In that, which elements are called D block elements? What are the D block elements? So which are called D block elements? We have actually many definitions for these D block elements. In that, one of the definition is the elements in which the differentiating electron enters into, mainly the elements in which the differentiating electron enters into n-1 d shell is called D block elements. Okay, so the elements in which the differentiating electrons enter into n-1 d subshell, D subshell, are called D block elements. So here what is meant by n-1 shell? If we say n-1, we should mention shell. Okay, shell, and we know that each and every shell contains subshell in it. So if you look at the atom, it has a nucleus in the middle and it has the different shells around it, right? So if we think that this is the outermost shell, that becomes the N shell. Okay, that is called N shell. Now which one is the N minus 1 shell? This one. This is the N minus 1 shell. Okay, and here different shells are again classified into subshells. These shells contain subshells. So we know that first shell contains, for example, if you take one more shell here, this shell contains only S, and this shell contains only S and P. Third shell contains S, P, D. Okay, so here in this, the outermost electron is entering into N minus 1 D subshell. Means the D subshell is present in which shell? N minus 1 shell. Okay, so here the elements in which the differentiating electron enters into N minus 1 D subshell are called D block elements. Okay, so here mainly the electron is entering into D subshell, that is of N minus 1 shell. That's why these elements are called D block elements. Okay, next, here D block elements are also called transition elements. Okay, and here in these elements, actually what we are saying, the electron is entering into N minus 1 shell. That means it is called penultimate shell. The elements in which the differentiating electron enters into penultimate shell are also called D block elements. We are saying that D block elements are having many definitions, right? In that, first one is the elements in which differentiating electron enters into N minus 1 D subshell are called D block elements, and here the elements in which the electron entered into penultimate shell. Penultimate means inner shell. From the outermost, the second shell is called penultimate shell. Okay, so here the elements in which the electron enters into penultimate shell are also called D block elements. Okay, next, where can you find these D block elements in the periodic table? Okay, so here we already discussed the periodic table and we know the different block elements of that periodic table. So if you look at clearly the periodic table, the first two which are in purple color, so these two groups or these two groups elements are called S block elements. First and second group elements are called S block, right? Here these two, this is the first A group or first group. So according to the new recommendations of the IUPAC, now we are writing only 1 to 18. So this is the first group. So first group, second group. These two group elements are called what? S block elements. Why? Why these two are called S block? Because the differentiating electron enters into S orbital, right? Next, from here to here, these are called P block elements. Why these are called P block elements? Why? Because from the third group to 18th group, the differentiating electron entered into P subshell. So that's why these are called P block elements. And here you should remember one more point, that is in S and P block elements, the differentiating electron enters into outermost shell, that is valence shell. But in D block elements, in between S and P block, we are placed D block elements. Moseley placed D block elements in the middle of S and P. Here in the D block elements, the differentiating electron is entering into D subshell. And where is the D subshell? In the penultimate shell, that is N minus 1. Okay, so if the electron enters into penultimate shell, that is called D block element. Okay, so D block elements are placed in the middle of S and P. And where is the F block elements? Here, which are in blue color. Okay, F block elements here are in blue color and S block elements are in purple color. Here P block elements are in green and D block elements are in red color. Okay, so the red color elements are actually D block elements. Next, so here P block and D block red color and S block which are in purple color. Next, here these are the F block elements. Okay, next, here S block elements. Already we discussed S block elements. Here S block elements are actually more electropositive, highly reactive elements because of highly electropositive nature. So S block elements, generally first group elements are called alkali metals. Don't forget the common names of these groups. Okay, first A group elements are alkali metals, second A group elements are alkaline earth metals. So these alkali and alkaline earth metals are highly electropositive and they are more reactive. Okay, next